Hey everybody. Today what you're going to be able to see here is a clip of a larger video on dealing with, finding, determining vertical asymptotes. In this clip you're going to see kind of a walkthrough of determining a gap in a function, as well as like maybe the first time walkthrough on a left side and right side limit check to determine nature of the curve. Okay? I hope this clip helps. Good luck. So let's take a look at the problem on the screen. So what we're going to do is we're going to go through, and if you read that question carefully, you'll notice that what I'm talking about is making a partial sketch. Like that is, we don't really have all the tools at our disposal yet to be able to sketch this one really accurately. We got pretty good tools, but not everything. So what we're going to do is we're going to use our intercepts and our vertical asymptotes to make a really good sketch for that function. This is going to require a ton of work. And so since this is the first one that we're going to go through as a group, then I want to maybe lead you on this one a little bit. We're going to find a number of things. Like you're going to do like a page worth of work to create a sketch in like the bottom corner of your page. Okay, we're going to do a lot of mechanics on this. And because we're going to use a lot of mechanics, then I think it's really important for us to put down some little headings every once in a while. So let's say that I was to walk through this problem with you. What would I go through and do first? Well, the first thing I always look at is my function fully simplified. And so it is worth going through and saying, well, I can factor the top, and I can factor the bottom. And after I factor that, I notice that I can reduce that function. That would always be my first action. Can I simplify what's in front of me? Now, the other thing that comes from that, if it does simplify further, is we just found out that we have a gap at x equals 1. So that's a piece of information I'm going to kind of like set aside for a second. Or at the very least, we could also then go, well, I could also sub my x equals 1 into my simplified form to calculate the function value there. And so when I do that, my x value becomes 1, my y value becomes negative 2 over 2, so that's a negative 1. So I just found out that I have a gap at x equals 1, and the specific point where that gap exists is at 1, negative 1. Okay. I still haven't done anything that the problem asked because it said using intercepts and vertical asymptotes. So the next thing I'm going to do is I'm going to jump in and I'm going to find my intercepts. I imagine for a lot of us, finding intercepts should be pretty easy. So to find my y-intercept, then my x value equals 0. And I'm going to sub that into my simplified form. So when I do, then I'm going to end up getting a y value of negative 3 over 1, which is negative 3. Then I can go ahead and I can find my x-intercept by setting y equal to 0. And I would hope that we come in on this line. Now, it's weird at times, I'm just going to hop off onto the side, that some of us come to that line because we had this fraction. And we may have said to ourselves, oh, well, I can just like get rid of my divide by, so I multiply it out. And I would not think of it that way. Rather, let's rely on some of that information, that theory that we already have. How do I make a fraction value equal to 0? Well, my top has to equal 0. And so what you'll notice in blue is I set my top to equal 0. And now I can solve for that. Okay. What I found then is my graph has a y-intercept at negative 3 and it has an x-intercept at 3. Now we're going to jump in and we're going to deal with our vertical asymptotes. And so what you see in the top left of your screen is that's just our simplified form for that function. What I would do is I would put down another little heading. And so I'm going to put down a little heading, just VA vertical asymptotes. Well, we should be able to read from the green where my vertical asymptote exists, because I can see that fraction is fully simplified, and so whatever value makes my denominator equal to 0 is the existence of my asymptote. So let's make sure, though, that we don't say, hey, my vertical asymptote is 1 or -1. Keep in mind that what we're talking about is the equation of a line. So we have our vertical asymptote at x equals -1. You can simply state it. And now what we need to do is to examine the nature of the curve. So I need to deal with how I approach -1 for the function x minus 3 times x plus 1. One recommendation I would make for you is always write your left side limit on the left and then write your right side limit on the right. It's just so that then when you go to take this information and transfer it onto a graph, we're not having to flip across and put the left side on the right side and the right side on the left. It can get confusing. So for us to go through, my left side limit is on the left and my right side limit is on the right. Okay, let's walk through that left side limit now. So I see the equation of my function, and my limit says, make your x value approach -1 from the left. So our x value is going to get so close to -1, we can treat it like it's -1. So we sub in -1. Okay, well, if I sub in -1 on top, I get -4. And if I sub in -1 on the bottom, I get my 0. Keep in mind that every time I make my substitution into the denominator, I should get 0, because the whole reason I chose that value is what made the bottom 0 to make my fraction undefined. So if I ever make that substitution in on the denominator and I don't get 0, I know I goofed up somewhere. Okay, so there was so close to -1, we could treat it like it was -1. But now we have to remember it's not really -1. It's a little bit to the left of -1. Now, there are people who will go through and on their number line, they're going to think in their head that like a number to the left of -1 might be like -1.1. And I'm going to argue to you, that's fine to think of, but I think there's a better way, that to say any numbers to the left of -1 are bigger negatives. And if we just think about bigger negatives, then you're going to find that you get to calculate less. Okay, so now the second part for us to go through is we need to realize that we didn't really sub in -1. We subbed in bigger negatives than -1. Well, this is kind of the next approach then. That really what we have then is not -4 on your top. We really have a bigger negative than that -4. And that I find sometimes students like to put a directional symbol on numbers that aren't zeros. My recommendation to you is don't do that. It really gets confusing when you start to go through and you see all these directional symbols everywhere. That it's a really important process for us to understand that we really don't care about that directional symbol on -4. Like, I want you to think about it this way. Like, on your number line, if there was -4, and say you went calculated and you got an answer of like -4.001, or you got an answer of like -3.999, wouldn't you just round both of those answers, or want to round both of those answers off to -4? Like, you just want to come to there. That directional symbol on my -4 doesn't really matter that much. However, when you look on a number line, if I am a little bit to the right of 0, then I'm like 0.001. But if I'm a little bit to the left of 0, I am negative 0.001. The sign of my value completely changes. And so whether I'm on one side of 0 or the other side of 0, that matters a lot. Whether I'm on one side of -4 or the other side of -4, who cares, really? So when you look back up into that limit, I don't care about my directional symbol on that -4, but I do care about it on my 0. So now when I look into my denominator, my x plus 1, and I imagine subbing in a value a little bit to the left of -1, then I'm going to sub in bigger negatives. And so if I take a big negative and I add 1 to it, then that adding 1 won't be enough to take that big negative and turn it positive. My denominator will always be negative. And so I put on my little directional symbol on 0. Now that we have it to that point, we should be pretty good. Deal with your signs, deal with your concept. So I have a negative divided by a negative, which is a positive, of which we won't write that. And then I have 4 divided by a really small number that's always getting smaller, means I get a big number that's always getting bigger. I have infinity. Okay, let's try our right side limit now. So we're going to go a little faster. Now I'm imagining I'm subbing in -1, but on the right of it. So I start off so close to -1, I sub in -1. And now I have to remember I'm not really subbing in -1, I'm subbing in a little bit to the right of -1. Well, numbers on my number line that are a little bit to the right of -1 are smaller negatives. It would be like -0.9. So when I look at that denominator where my 0 is, I'm really taking a smaller negative and then adding 1 to it. Well, if I have a small negative and I add 1 to it, then that +1 is going to be enough to change it to a positive value. And so I can go through now and evaluate. Well, I have a negative divided by a positive, which is a negative. And now I have my 4 divided by a really small number that's always getting smaller. It means I get a really big number that's always getting bigger. And there we go. So there is all of my stuff, all of my work to be able to go through and produce a sketch. The job now is to take what we've got and try to produce a picture with it. So here we go.